Now, Nick, you've been a software developer for actually pretty much as long as I have now, just about 20 years or so, a couple of decades.
For
You work for EPAM in the Netherlands, been software engineer all the way through to head of development, and you're leading huge development teams, right?
I've been working in it all my life in software, and it's amazing times now with everything which is changing. The whole software development life cycle is changing, and I'm super pumped to be part of it. Yeah.
Awesome. And you also you work on an open source project, Refact AI, which you built, I believe, with a previous OpenAI researcher. Is that correct?
Yeah, very much true. Yeah, we're developing an open source agent and code assistant. The things are kind of blending these days anyway. So very exciting to talk a little bit about that as well, and how we applying that work and
Awesome.
how we applying the fine tunes.
Well, Nick, it's a pleasure to have you on stage with us. I'll pass it over to you, and looking forward to hearing what you've got to say in and around the fine tuning space.
Thank you very much. Again, Simon done all the work for me in terms of introducing myself. So all these things which needs to be said are said. The last thing is just you missed my very funny tagline in X. So add the vibe coder to one of the follows out there. And yes, indeed, Refact is an open source AI agent and assistant. The company has been founded by a former OpenAI researcher. We got featured by Gartner Magic Quadrant, partnered with AWS, featured with DeepSeek, InfoCrunch, all the other guys. Very proud with our more recent results in benchmarking on SWE benchmarks. We already submitted our pull request into the SWE website, so looking forward to be added, and you already can read details on that on our website. Now, yes, and we are very proud to work with a number of large enterprises. So what I'm going to talk today about is indeed fine-tune. I'm going to talk about code completion. I'm going to talk about some of the use cases, agents. Hopefully we'll have some good Q&A there. And the kind of the challenge for me with the setups like this is I have all the anxiety of being a presenter on stage, but I don't have the audience responses. So bear with me at the comments as you go. I'll try to look at all of this in the end of the session. So again, kind of the assumption which I had going into this talk, usually I talk about how the agents work, how our tool works inside out. And today I was asked to talk a little bit more specifically about the fine-tune cases. So for those who kind of not really familiar with that, let me take you and explain that a lot of the details. So as we all know, the large models are large for a reason, because they trained on gazillion of data. And the example here, which I have that, for example, written Llama 4, not even the biggest one, been trained for an equivalent of 7.5 million of hours on a GPU. So it's a big task to train that. We obviously, most of our mere mortals cannot do that. But what we can do is we able to adjust some part of it, right? Customize some behavior of the model and see how we can better use the capabilities. And in general, by using the existing open weight pre-trained models, we can improve performance for specific tasks without kind of breaking the bank with all the computational resources required for that. To do that, there is a clever math works in play. If someone is asking a question, am I showing linear algebra? Yes, I am. So the very basic idea behind this clever trick is to use a smaller matrices which store the adjustments to the weights of the open models, and then applies these weights either on the fly or kind of reconfirm. So I'm not going to go and kind of walk you through lines of code which show you exactly how to run PyTorch or how exactly run Hugging Face transformers. There is plenty of tools out there for it. There is even better kind of tools today which allows you to do fine tunes. I mentioned some of them here. I really like, for example, Onslaught, the documentation they have. They have really deep coverage on how to prepare your data for fine tunes, all the different data sets and details. And they also allow you to do it with the fairly low resources, doing some clever tricks to run it even on your laptop. Transformer Lab has a nice UI as well to help you create data sets even with use of LLMs. And yeah, when we talk about the closed models, even the closed models allow us to add some fine tune. So OpenAI had fine tunes jobs API from the beginning of time. Anthropic offers some support of fine tunes via AWS, and for example, Mistral also providing the support. And the best part about what they do, which I really like, is they allow they don't really change the price of running your fine tunes model. So there is no difference between whether you're using their model as it is or fine tune. So that's kind of a nice thing about it. Now, and again, I think fine tunes have kind of a bad rap, and one of that is because it takes a lot of time, money, and effort to prepare the data. Well, it used to, but now we live in a time where we can generate synthetic data. We can generate data with the use of advanced LLMs, and from that create the data sets which we use to fine tune. And again, the data sets is essentially the examples of what we tell in the model is right behavior, and sometimes we even can add the wrong behavior. And we usually then test those examples with a loss function. And here's the example of the loss curve. And then we split them to see if our behavior is adjusted to desired. But also need to be done with caution, because there are a number of papers, and the one which I'm citing right here on the screen is the one which basically mentioned that while we align the behavior of our models, while our loss curve is moving in the direction we want, we also override and make the model forget the behavior. So the takeaway from that is the fine-tuned models which we created should be used for only in this particular use cases which we created for, and not used as your general model for your main agentic use cases. All right, so let's jump right into that. So fine-tune for code completion. So again, code completion is very much a new thing. It's kind of intelligence on a steroid. It's a completion of the lines in your project, for example, in your file, right, in your IDE, as one of the use cases which are very often used today. And it's done with a special kind of models. Usually it will be fairly small model, the ones which are optimized for speed, because if you use a large chat model for this purpose, you will have a really long latency, and you would need to wait for a long time. So normally the models which you see are, especially in all the open source projects, are derivatives of one of those which I mentioned here, right? The DeepSeek Coder, Qwen-Coder, Codastral, StarCodal, those families of models have been trained on large data sets and have amazing performance to speed in terms of how they work. So the downside of how the model's been trained is the fact that they train on the average let's say, open repositories. And that's great on average, again. But when it starts to suggest you pieces of code, they might be maybe slightly less relevant. Maybe you have your own standards on how you're doing the logins. You do login. You have own standards how you're doing. Yes, the security patterns, you name it. Usually, if you take average enterprise and look at their the microservices set, you will see that all the microservices are pretty much a boilerplate with some logic added on top of it. So it will be nice if our code completion models are actually being able to capture this boilerplate and use it. All right. So again, as part of Refactor AI, we have a kind of complex toolset, but one of them is, beside the agentic part, which actually done all the work, we have the server side, which can use models and can actually help with performance of fine-tunes. In our particular case, what we allow to do, and this is kind of a screenshot from part of the UI for this experience, but the screenshot is basically, shows that we select a number of different projects, which we have, and then select the target model, which we use as to fine-tune further on. And that's actually really helpful setup. How does it work from inside of it? So behind the scenes, when we're doing the dataset preparation for the fine-tuning of the code base, so we obviously took the code base files. In our toolset, we have the idea of the privacy guardrails. If by some reason in some files you decided to store your passwords, SSH keys, tokens, whatever, those files are added as those which are excluded from the fine-tuning process. We obviously then have a selections based on the relevant extension and the size of the files, removing binary files, removing the large JSON and whatnot. We also remove the external vendors if we're able to identify them through the accompanying license files, something like that, or license headers. And then we also remove PI data. We have some fairly simple algorithms which try to remove emails and stuff like that from that. And just like that, we get ourselves a data set from all different code base which our customers, our users have. We split them on chunks based on the desired tokens. Usually it might be something like around 2,000 tokens or so, with some overlap, which helps model to kind of look at it from different sides. Those chunks are usually shuffled, and then this is how the data prepared for that. But again, like I said already, we live in the golden time for the for dataset preparation. And even better way is, if you can afford it, is to actually run the LLM model from for these pieces of code and put in the inline comments. And those inline comments will be really helpful from when you yourself would want to type something in and ask a code completion model to finish it for you. All right, so code completion is kind of not really the most exciting part today. Everyone excited about using of agents and using of tools, and this is where one of the next use cases which I have. So we had a case where we needed to connect the agent with a large database. So normally, right, as you've seen in many articles online and blogs posts and so on, or even using yourself in ChatGPT, you can just add tables definition right there. But if there are hundreds of tables across multiple databases in terabytes, how do we make sure that we make a performant queries? So the first part is, again, the data preparation, right? And this is where LLM serves immense value. In most of the examples online, you would see that the people assume that the kind of tables and columns in your database are self-explanatory. That's not always the case. This was our case in this particular story. So we had to analyze every column in every table, write additional details about it. We kind of doing the exploration of what type of data in there, going all the way crazy ways to then write even details about the try to infer details about the relationship between the tables and the descriptions of that. So all of that led us to being able to then put this data into some semantic search, some sort of a RAG search, where we can add tools for our agent to find relevant tables, and also have a more simple way to ask details about particular table. And we also added ability to actually run some queries. In some cases, it was very useful as well, but be careful to put the guardrails in such cases, as run on selects and doing on timeouts. So we now able to generate queries, but the generation of them slow, right? We have many tool calls. We limited by the architecture of RAG, which is top N. There might be some missing tables, not returned to the context. And also the models can generate kind of a slow, poor joins and unoptimal requests to our database. So we decided to go and look at it from another side out. So we took a log of actual production queries, which was millions and millions of queries. We deduplicate them and actually ask our agent now to do the opposite, solve the opposite task. So explain for each query from our production database what was the query tries to do, now that our agent have ability to go and look at the tables and have a definition of tables. From that, we actually created a really nice training data set for our fine-tune. And again, the things which at least was relevant here is, in your real production, you will have some more usage of particular tables and less usage of other tables. So we had to kind of look at the distribution and making sure that all the relevant tables are in there. So yeah, from that we created the subset and use it for fine-tune, right? Essentially what we did, we put this whole SQL generation into a special tool called text-to-SQL tool, behind which the agent was basically routing requests to our special small fine-tune LLMs, which now has been blazingly fast and has been provided a lot of relevant requests for us. So that's kind of has been one of the kind of in-depth cases on that. We still can add other tools if we want, but we need to make sure that we tell in the system prompt or to our agent that first we try to use this tool, and then if it doesn't work, then we try to fix it with other tools. So let me probably talk a little bit more about not just how the fine-tunes can be used to kind of adjust a particular model and make it tuned, but how can we use it for trajectories and tool calls, which is kind of the more relevant today. So again, the models hallucinate, right? You see all those headlines all the time about some company tries to do something and then kind of had to roll it back. And my kind of look at that is actually summarization of news is a harder task than writing code, because code can be tested, right? All of us who had the proper software engineering background are very much familiar with what the software quality means and being able to run that. And yeah, we in Refact been adding all kind of different tools for model to be run. And the main idea of this getting feedback from the tools, is that we allow the model to be able to run auto test, or if by some reason you don't have auto test, you can try to compile a project, look at the warnings, linters. You can even look at the execution logs or even from browser. But the main idea behind it, as you get the more feedback, the quality of the agentic work improves. One of the results which we've done on the polyglot benchmark, and again, we used the benchmark which was created by founder of Aider, and our difference of how we tested it was actually allowing the model to verify itself with a test. And what you've seen here, that the model has drastically improved how it runs, how it provides results when it has the right tools to verify itself. Now, okay, there is more tools on the horizon. Unless you've been living under the rock, you already use MCP, or you hearing it or seeing the news about it every day. So while MCP is a really nice standard, which now improves ability to integrate all kind of different services in APIs, it's also a nightmare for those who work with LLMs to try and manage this behavior. So with MCP, I for the first time seen actually error from OpenAI about that the amount of tools has been exceeded. And believe it or not, they have 128 tools which they support for tool calls. And even if you add 128, the performance between selection of them would be really poor. So you need to have a really be smart about what tools you add to the models, even if they fit the limits, right? Because there are now enormous amount of trajectories, and models struggle with all of them. But this is kind of the example of the complex setup, right? We expect the model to be able to go to GitHub to get information about the bug. We want our model our agent to go and get some additional data from, let's say, our production error logs on Sentry or whatever you use. Then find the relevant unit tests, then replicate, make sure that we add the right things to the unit tests, run them, continue to make changes, and so on and so forth. Those are really complex trajectories. And to make them right, this is where the preparation of the fine-tunes from your chats becomes really, really handy. And you can extract them from saving your agent logs. You can also, which is more relevant for on-prem, and in our case, we have support for on-prem as well. On-prem is kind of a nice thing because it has it allows us to kind of have a better security. But the problem with that is the open models which we run on-prem are still not on par with the models which we have from closed providers. So one another way to prepare our synthetic data is actually we can use the tool calls with advanced model and Claude from Anthropic, and from our experience is today the most advanced model when it comes to working with programming tasks and calling the tools. And what you can do is you can run number of chats, run number of prompts from your expected behavior, save how Claude was calling those tools and how Claude was doing this work. And then from there, you can create your training set and then feed this training set into, let's say, your open model, which will be running on-prem, right? You can then fine-tune and use your cheaper model, use it on-prem or use it in your cloud environment, but just for this trajectories have it cheaper. Yeah. Yeah, I kind of going into the end of my prepared slides. In general, what I wanted to say is that today the fine-tune becomes really, really simple because the tool set is already there, which allows to do a lot of stuff really, really simple. You don't need to look at the TensorFlow code and understand stuff. Things are really, really simple today to be able to do it as developers. The preparation of the data set is also improved because we now have the advanced LLMs, which we can delegate the tasks to prepare synthetics data set for us. If you haven't, go and try our agent on Refact AI or join our community on Discord. All right. I have a question here. Also, AI offers constant availability, judgment-free support, and personalized interaction tailored to each user. Not much of a question.
I have, I can go through the questions. Thank you very much. First of all, I really appreciate the session, Nick. Got a couple of questions that we've starred here. Question from Richard. Richard OC. Anyone know of any good GUIs for fine tuning on Mac OS? This question.
Yeah, I think I mentioned that in my slides. I really like Transformer Lab, I believe they called. Really nice tool. Again, open source, have a bunch of plugins. I was really impressed with how it's done. So definitely would recommend. And I use it on my Mac. Yeah.
Awesome, thank you. A couple of others. Interesting question here. We always take this for granted when someone says, "Oh yes, this model was trained on 15 trillion whatever." What does that actually mean, though? When we think about what a token is, whether it's a word or a half word, what does 15 trillion actually look like?
All right, you're gonna make me do the math in my head. All right. So on average, I think the token is roughly 3 or 4 symbols. Again, depends on the language, depends on the number, but it's in general the notion of all amount of the data which gets into that. The numbers ridiculous, right? So that's you can think of tokens just as the a number.
Yeah, awesome. Thank you very much. I think that's pretty much all the questions that we've got. In terms of folks who are wanting to try out the tool, what's the best way to get started?
Right. So again, and I was okay. Is there a question? Or I'm not quite sure what the questions which you got there. Let me ask you your question first. So those who want to start, like I said, we open source. So most of our code is available on the website, on GitHub, and fine tune of your code base is the easiest way to use it. Fine tune of trajectories is something which we don't have in our open source tool, but it's something which we support our enterprise customers with.
Awesome. Okay, awesome. Thank you very much, Nick. Real pleasure to have you join us, and appreciate you supporting the conference.
Glad being here. Thank you.
Thank you.